Okay, that. Okay, good. I think this works. Okay, good. So let's see. Yeah, basically that's basically what I'm gonna do. Jadi header punya entry size, magic number, and also I think apalagi ya entry size ada magic number jelas ya untuk ini making sure that, and then there's gonna be entry size, and then obviously entry ini sih entries count ya. You can have multiple entries, you can have a lot of entries here, right? This means that I don't need footer no more. Actually, if you think about it, I don't need footer because yeah, there's no need for that. Simply no need for that, really. Yeah, there's simply no need for the footer, really. I can just read the entry, index entry. I can just like scan each of them. I can linearly scan the index group headers, all the headers, and basically that's it. Because now the thing is, we can also, because we are because we split this by groups, this allows us to parallelize search, right? Search can be parallel now because of this grouping, and also once again, each group can have multiple different size, which might also optimize things a bit. So basically, if you want maximum concurrency, you can split that as much as 20 groups, for example, 20 groups and stuff. Yeah, 20 groups is awesome, right? But the thing is, yeah, I'm not sure. Anyway, let's see if I can hear my voice. My channel. Mute silence too. So I need to change this. This is index group header magic number. Yes, magic number is simple, isn't it? That's it. Yeah. So red index header, and that's gonna be a index entry. Yeah. And then also, we don't need seek ya. Jangan. It's gonna be complicated. This is gonna be red index group header, right? So put it here, the opposite. So red index group header maybe even here actually. Buffer obviously in index group header. Index group magic number basically. This one has a magic number, entry size, and the count, right? Basically, that's it. And this count for this group right here. Now, yeah, entry size obviously that would be a edit section. The thing is, my friend, you have an entry size. So the entry size, obviously, you need entry size in here. Oh, I'm so confused. Which one should I use? Entry size, entry size. That is wrong if you use that, but yeah, anyway, I'll use this. That's gonna be the index group, and that's gonna be index group table entry. Obviously, we can just we can populate that for sure. So how would you populate that? Yeah, simple as we can have a multiple of the entries, and then it's just basically, yeah, we can populate the group entries for sure. It's just fine. Thing is, so yeah, basically that's gonna be it. Red index, apa namanya, group table ya. And so how many, right? You get So just gonna put it in here, really. I'll put it in here. Gonna be a index group, you know, table and this and this count. That's it. That's it. That's what it is, really. And the buffer will be as big as we can just directly write the. It's fun to just write. I think we can just write so for I don't like that, so I'm just gonna use ss like t, really. Or really, that's not possible though. That you don't, not possible actually. It's not possible to do that, really. I'm just basically we're just putting the into the f, right, which obviously we can buffer this. We can buffer this for sure. What's right there? And we can buffer for sure. Yeah, we can buffer, but you know, we can have a buffer as much as you know, maybe 3 or 5 entries, maybe even 10 entries, right? 10 entries could be good. It's fine. 10 entries basically, and then we can have again, so basically available. Then, or you know, size of buffer is good enough, really. Okay, this is why do I do this ya? Kenapa aku pakai buffer? Kenapa aku pakai struct makan ini? Don't need that, man. Doesn't need 10 of this, and that's fine. I keep using byte buffer. Byte array. Using that somehow. Right. So we're gonna be copying that into here. So for every of this, because it's basically it's gonna be buff, you know, buff of apa namanya? Buff index 0. And size, the buff size is just size of buff. I hate this keyboard so much. So let's see. Buff idx is the this is pointless. Why are you doing? What are you doing, my friend? Oh, my friend, what are you doing? What are you doing? Seriously, what are you doing? You can just, what is this, man? What are you doing, bro? You can just perform an f write into the from the entries, from the entries right here. So really, so from the entries, you know, as much as, I don't know, entries, you know, 5, so you know, to write is basically just as much max of you know, entries count, or and this counts time ini obviously, size of stock table ini index entry, or antara, you know, as much as that, bukan max ya, min. I think it's better to be min, just or max nggak sih, min obviously kocak. So how many entries do we have? And also, let's say I want to buffer 50, right? 50 entries. So basically that's it. I just need to do that. Basically, just 2 write, 1, and that's it. That's it. Obviously, I don't know why my operating things so a bit. Then we can have this. Now, of course, my friend, right there, return 0. But what are you fucking punching? Right, and that's it. So that's it. We're at the next group table. That's it. What else do I need to do? Now we can define how big the group is, right? How many entries can we hold in a group? Let's say, for example, I want to hold a million, or a million is too little. 15 million is good. Maybe even 30 millions, because 30 millions is apa namanya, huge ya. 30 millions itu is only 2 gigabytes. It only needs 2 gigabytes of memory. Now maybe 2 gigabytes is too small, too high, but obviously it will be configurable. So the thing is, yeah, that's fine. So I'm gonna be you know, group max entries. For example, I want 20 30 million, so 30 million entries inside a group. And yes, this is not needed. What is that? Maybe I do need that. What the fuck? And this is for the group group entries. So yeah, we need group entries basically, which is a slice new box entries. Yeah, have to allocate that much. Now it could not work though, actually, karena aku malah dipatin actually. So size of struct index entry. Yeah, it could not work actually. It could fail. This is yeah, it could fail though. It could fail. So I just what did I click on? Am I smart or something? Yeah, group entries count like entries. It might fail because this is already 2 gigabytes, and that's, yeah, this is very close to atau gini aja. So the target is, the target is 1 gigabytes, right? How many entry calculate how many entries that can fit memory, right? And so basically we can do this, size of stroke infinity, right? And obviously it will be, yeah, how much? I'm curious though. I'm very curious. Group max entries. Please, LD. I'm just gonna exit this. So let's see. I'm curious. How much is that? What is that? Make obviously lots of failure. Gonna comment them out. Many indices. Let's just comment them out today. I hate this keyboard. Not seriously. Red index is N3. Index mode-nya index. Yeah. Okay, index mode. That's weird. Why did I delete that? So index mode is simple, frame size and offset within. That's it. That's what it is. So that's it, I think. What else? Incompatible integer to pointer conversion. So this one, yeah. So can I do this? Can I do this though? Is this even? What? Min. We don't even have min. We do have min. I don't like min again. I have max. So min let's cast it min in here. Max. Oh, okay, it's already here apparently. Aduh, kocak. Let me see. What? I'll put it inside the utils for sure. Why do I keep forgetting things, bro? Incompatible, blah blah blah. I keep forgetting things, right? I don't understand. So bad address, of course, my friend. You haven't. So that's because. Wait a second. What is that? What is this? Is this? I returned one, by the way. So, oh, wait. Huh? What is this? A map or the? Sure. So what is this? Who is printing this bad address things? Who the fuck is printing that? I'm just gonna clean and then just gonna run some debug here. What is this? Who is that? Who is that, Miss Zuzin? What? What is this? It could be. Oh, yeah. I have no idea. So I really don't know what is causing this. It might be. Okay, let me just trace this. The easiest is just have a debugger. I have a better debugger anyway. Make clean all actually. Make clean all and shits. I'm just gonna do a make G and prop, and then I can run. It's lagging. It's crazy. What is this? Do I need a better CPU? Right, let's see. I'm gonna be debugging that. I'm gonna be running a debugger here. What is causing the error, my friend? Let's see. Okay. Okay, so apparently it's this one. Out file. Okay. I see, I see, my friend. I do. Output. That's it. That's the fix. Make it rock. Oh yeah, lupa. Just gonna tap now. So yeah, that's it. So the max entries of the group is going to be this much. 22 million. 22 million of entries, which is awesome. Yeah, that's to reach 1 GB, it only needs that much. And yeah, that's good. That's awesome. That really is awesome. So we can, yeah, that's good. Fit in 1 GB of memory. So slices in indices. This might fail, by the way. This might fail actually. This might fail actually, but I don't know. Maybe it will, maybe it doesn't. Let's see, route index header. We should be, this should be good. Should be good. Route index header. This is good enough, and we will perform this piece of shit. Then we will have an indices here. Instead of doing this, we can put that in a group, right? We can put that in a group, and we're gonna flush them after that. So, I have a problem actually. It shouldn't be in the header, my friend. Yeah, kocak banget ya lagi. Karena the thing is, to, you know, that has to be put in the end. Ya, itu tuh harus ada diputar. Ya, salah gini. Salah. My friend, you are wrong for this. So, yeah, that is wrong. Ya. Harusnya ya itu harus diputar, ya. Doesn't make sense we put in. It doesn't work. So, the index group table itu harus is put at the end, ya. So index group table, and also, yeah, that's it is put at the end. This has to be put at the very end. Ya, karena belum tahu entry-nya berapa, mau berapa entry kan nggak tahu. Kocak lu. Ya, kocak. So we need to write this in here. Just entry count. Gimana tahu entry count? Ya, gimana tahu entry count? Nggak tahu. Yes, I also need this as well. So I need to have this on my main. So build index main. I also need this right here, basically. Malloc, how much is this? Yeah, that's it. Obviously, this is wrong. Our is fucking stupid. Group table entry. My guys. Okay, this is confusing. Group table entry. Group table entry. Group table. Group table. Oh, yeah, actually. Then there's gonna be a group table entries. Yeah, group table entries. Yeah. I really hate this keyboard. I really want to use keyboard. What's this? Asli lah. Enak banget ya asli keyboard. Seriously. Itu nggak ada banget keyboard asli. I hit tapi udahlah. So we will be putting that into a slice to do, obviously. Yeah. If it failed, n of the group indices, group entries, yeah, group entries. That's gonna be that. It fails. Now, I also need to make sure if slice get length is a group method. If that's the case, then we have to reset that. We have to reset. We have to reset this. We have to reset the group entries slice. And so we will flush that. We will flush this. We will perform a sort, right? We will perform a sort on that, and then we flush. We flush that basically. So yeah, yeah. So yeah, we need to first we need to perform a sorting on this, and then we flush that into our insta file. We reset that. That should be good. See, I think that should be good. Should be good. Should be good. So how would I perform the sorting? I mean, I can use radix sort, but how do I I have to, modify the slice data directly though, which might not be the best. But the thing is, yeah, I can perform the radix sort here. I have the radix sort here. I can use the slice entries for sure. And yeah, also, my friend, I don't need to have another bucket because that is not needed. That is just absolutely stupid if you. I forgot what is it. I think it's in the what's it namanya? Indexer. I believe it's indexer. Apa sih? Apa sih namanya? Index apa sih namanya? I really forgot what's the name of the program that I do. Tiny indexer. Indexing file sig table. File sig table. So it has a radix sort implementation in here. Let me see. Got a radix sort implementation. Where is it? Where is the radix sort? I'm going to steal that. It's my own code, by the way. Indexer C. I'm just gonna steal a code. The radix sort in here. Static. So yeah. I don't like this. Ini apa sih ya? nggak pas ini actually. It's possible. It's fine. It's really fine. Now, how many rows do we have? How many calls do we have? How many bucket do we have? Now, rows is I forgot how do I call this. How did I call this? Zero fill. I don't have zero fill. Zero fill is a mem set. Yeah. Yeah. How did I call this? How did I call this? This radic sort. So rows is 4 katanya. What is this? 4 rows? 4 calls and 1 rows. I fucking forgot how radic sort even works. My brain, bro. What is happening with my brain? I don't know. I really don't know what is happening with my brain. Why am I forgetting things, right? Why do I forget things easily like this? It's hard, it's saddening, it's heartbreaking, right? So I don't even know if this can be fixed. I really hope it can be fixed though. Really do hope this can be fixed. I don't know. Maybe I need more sleep or something. I don't know. So I need to look on how radic sort is implemented. Hah? You don't update, dear. Aneh, serius aneh banget. That is so weird. What is this? We will incorporate the SIMD later. Multi-threading. What is this two rows and calls things? I mean, if I see this calls minus 1, this is rows in here. So yeah, once again, I forgot something actually. So the calls is actually 4 calls and 2 rows in this case. The thing is, my friend, the thing is, yeah, this is manual. The thing is, if you remember from the radix sort, radix sort is, so the thing is, of course, we have a list of an array of numbers. For example, we have an array of numbers, and so in order to, so we have like, let's say 1,000 arrays of number, or maybe 10 10 atoms in our array of numbers. In order to sort them, we split the number into digits basically. And in our case, in what I do usually is just to split them into 8 bytes, right? Or 8 bit, right? So I split the number into 8 bits. So if I have U64, an array of U64, that means that I will be, you know, the thing is I have to convert that into multiple. Yeah, no, you don't need to do that. You can use union though. I can use union for sure, but the thing is, yeah, I can use union actually. I can use union. I can convert that to union. Oh, that's actually correct. Yes, I can convert that to union. So yes, I can convert that to union. In fact, I can probably, yeah, I can totally convert that to union. But the thing is, yeah, I can. Mostly, I need to provide this radix sort. Yeah, I need to provide this radix sort. Sebentar, nggak bisa sih kasih. Gimana caranya? The thing is, my friend, the thing is, these. Okay, so this is one contiguous. I mean, the thing is 1 byte as one value. U64 is 1 byte as one value, and in this case we have a U8, an array of 8-bit integer. The thing is, well, of course, the memory layout is the same, right? The memory layout is the same, but apa namanya? Sebenarnya kan iya, sebenarnya sama memory layoutnya kan sama aja. Tapi how do I treat the U64 as basically an integer, an 8 an 8 element, apa sih? An array of 8-bit integer, and with 8 elements, right? 8 elements of that. How do I treat that? Because this is how the radix sort. This is how my radix sort works. It's basically it works on the 8-bit of a. So kan nggak mungkin aku buat another entries with Di-chop gitu nggak mungkin. Now I might be able to use union, and you know what, that might actually work though. Union might actually work, right? Using union might actually work. So yeah, I think it is possible to use union. I think it's possible to use union. And how do I do that? I'm not sure how do I do that though. Let me look up on the C union, like in deep dive on the C union. Let's see. Writing large programs. What is this? What book is this? What book is this? Okay, the more modern approach. So unions. I really want to deep dive into unions, right? This might. So a union, like a structure. So union like a structure consists of one or more members, possibly of different types. However, the compiler allocates only enough space. La 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 la. Yeah, I know that already. I can just open it if I need it. Oh, this is good actually. By the way, I'm just curious. Apakah keras union? Okay, that's the same thing actually. Good, good. That's that. Good. If it has that, it's good. Point 3. On. Ini beda bro, beda ya. Kalau ngomongin ini agak beda nih karena apa namanya ya, ini beda. It's simply different. Union, I don't think I can represent my index and 3 hours kayak gitu with union, and because the thing is, it's versus variable size. It's simply variable size, right? There is no bound on that. It's simply variable size. So, I don't know if I could save her though. I don't know. Tapi tetap aja ya, kalau misalnya katakanlah kita max ya, it is still going to allocate this much karena ini paling besar gitu. That's why it's very important to assembly. Use the raw memory and stuff like that. String copy C item design cuts B thread. No, I think here. Spawn thread. This is called obviously. This is called. We need an array whose elements are a mixture of int and double values. Since the elements of an array must be of the same type, it seems impossible to create such an array. Mixture of int and double values. Berarti ini aku mungkin ya key ini I can either my copy ya gitu atau langsung aja or it returns a union. Yeah, it could return union actually, totally could. Kalau ngomongin type safe, I believe C is not very strongly type ya. Pikir-pikir ya. Type itu kalau di C itu kan sebenarnya nggak begitu strong ya. In fact, yang strong it's a big type. Yes, C is weakly type. Yeah. Implicit type conversions and loose type checking. Yeah, basically. Yeah, exactly. Mesti it's in the warning. Mesti kan ada warningnya ya, nggak di enforce itu, nggak di enforce. Aduh. Let's go. Expect. Cancelable reader is interesting. Bagi sih. Gitu ya. Bagus ini actually, interesting. Cancel after 5 seconds, so it stops there. Epal, okay, that's cool. KQ, POSIX select. Well, shit sih tau gak sih? That's pretty cool, actually. This is good. Of course, you can manually manipulate those bits yourself. Of course, that's possible. But why would you do that? The program has this feature, so use this feature. So adding a tag field to union. Let's change. Mungkin aku bisa sih jadi hash. Really, this is not possible, I think. I don't think it's possible. That is very bragging. I really don't think it's possible. Is it even possible? Is something like this even possible? I don't know. I really don't know. But I think it's not possible. Because the thing is, look at this Python here. I mean, both are the same, right? Both are the same. I don't know why it's not possible though. Expression must be a modifiable L value. What is that? What really is that? If I go in here, what is that? It's really values.